I'm an immunologist, so this is going to be hilarious. Yeah, so I'm an immunologist, I'm a biologist, I specialise in the immune system. And I didn't always want to be a scientist, I very much fell into a career in science. I originally wanted to be a doctor, I wanted to study medicine like most failed doctors who end up in science. And my first taste of biology really was in secondary school. There was a guy a few years ahead of me in school, and he heard I wanted to do medicine, and he's like, hey, you want to do medicine? Here, try some biology, you know, it's cool, it's easy, you'll like it. And he was I was a bit wary, but he was from a very respectable, decent family, so I decided to trust him, and I took some biology for medicinal purposes. And it was amazing, it opened up a whole new world for me, you know, it was alluring and attractive, you know, there were fallopian tubes and yeast and all sorts, it was amazing, right? I was at that time of my life, I was 18, and I thought I was invincible. I said, I'm going to university and I'm going to go and study biology and there's nothing you can do to stop me. So off I went into the big bad world. I studied university level biology. But of course that goes hand in hand with university level chemistry. So already you're getting into some pretty heavy shit already, right? Before you know it, you're doing biochemistry. You're in over your head. You're up to your knees, even your eyes. That's why I pointed at my eyes. Complex chemicals. You have no idea what these chemicals are doing, but you're enjoying it way too much to fucking care, right? Before you know it, you're dealing science. You're selling science for money. You're giving tutorials to anyone who will listen, right? How could you sink so fucking low? But you like being able to afford to have meat with your potatoes, so you keep going, right? Basically, the only way to break free of this endless downward spiral of science and bad decisions is to sell your soul to a science cartel. And that's what I did. I joined a lab group at the University of Glasgow. I work about 100 metres down that way, and I'm currently I'm taking a stab at a PhD. It's really just been a prolonged exercise in keeping a low profile around the lab. But I'm about halfway into my sentence at the moment, and I've really, had time to assess my life choices right now. I'm thinking, how did I end up? How did I get here? This is not how I wanted to live my life. I said, come on man, you're 24 years old, you're a young foreigner in an exotic land, you should be going camping or having anonymous sex in public toilets, not hold up in a lab. Come on man, get together. It's very hard not to compare myself to my friends. A lot of them got their degrees and they left, they're travelling the world, or if you're in the Irish media, just emigrating, But of course I'm here and it's very hard not to compare. A lot of them have kids, can you believe that? Offspring. My mate has a son. I don't even have a bike. But I think in my line of research I can take solace in the fact that I work with cells, and that's like having millions of kids at once. So what we do is we get leftovers and blood transfusion bags, and we take it and we separate it into the different cell types and we do our science, right? And that's like having loads of kids, because just like real kids, these cells need attention and washing and feeding. But unlike my mates with their real life kids, if I get fed up with my kids, I can just fuck a load of bleach on them and be done with it. So, I'm an immunologist. I work on rheumatoid arthritis. That's an autoimmune disease. It affects approximately 1% of the world's population. Do you have it?
Yeah.
Sweet. That's never happens. I'm just going to talk to you right now, okay? Okay, so it affects you. There are 100 people in this room, that'd be so fucking statistically correct. But no, it affects 1% of, 0.5% of the room. And basically what happens is your immune system goes fucking batshit crazy and starts attacking your joints. And there's chronic inflammation due to immune cells rushing into the joints, and there's really, really painful. Are you in pain? Is that a weird thing to ask? Yeah?
Yeah.
That's good. That's because of me.
Okay.
That's because of me and my research.
Yeah.
No, but basically, right? Have your bones and cartilage started to degrade yet? Okay, that'll come. Don't worry. Yeah,
It'll all come to everyone.
No, just you. Grant, that was an ad lib I did not expect to have to make. But yeah, so basically your immune system goes mental, and I suppose as an analogy for that, imagine you're at home at night and you're awoken by the sound of an intruder, and so to defend yourself against this perceived danger, you arm yourself with a hammer. I'm left-handed. And then basically you start smacking yourself in the knees and in the elbows and in the fingers and the ankles, and it won't stop, and it's chronic and it's constant, and we don't know why, right? So, as researchers in the field of rheumatology, we ask three fundamental questions. Why is this happening? Why is this localized to the joints? And why won't it stop? So to address that first question, you can consult any journal or paper worth their salt, and they'll tell you. Do you have arthritis?
Sorry, do I?
Do you have arthritis?
Osteoarthritis, yeah.
Oh, it's close, it's close. join. Anyway, right, so you can consult any journal or paper worth their salt, and they'll tell you the risk of developing rheumatoid arthritis is an unfortunate combination of abnormal genetics, environmental risk factors, and just plain bad luck.
Rugby and 100 miles a week road running might contribute.
Can I do it again? I was looking forward to this punchline. Thank you. Right, so the risk of developing rheumatoid arthritis is an unfortunate combination of abnormal genetics, environmental risk factors, and plain bad luck. So it's a lot like being born in Aberdeen. So basically I work in translational immunology. We work with doctors. My boss is a doctor. I'm just the lowly scientist. And it's very good from a scientific point of view because it means that we don't have to wait to go to a conference or read a paper in order to, hear about the key findings and discoveries in the field. But from a doctor's point of view, it's great because we get to hear firsthand their opinions on key scientific theories, which is always a great laugh. And that's basically it. Yeah, that was a punchline. So I've been banging my head against the wall for the last 2 years, kind of trying to figure out this disease. I'm sorry, I'm no closer to finding any answers, but at least your meds are holding up. That's good to know. But basically, I suppose what's important about scientific research is that it's important to engage the public and let people know that scientists aren't just in some ivory tower. And mine is really, it's a top floor tenement flat. But basically, public engagement is very important. And I want to tell you that science is for everyone. And with that in mind, I want to tell you about how I used the power of genetics and science to decide who to vote for in the general election last year. And I know this probably isn't applicable to most of the room, so I might have to avert my gaze this way for some of the Scottish people. But basically, I'm in quite an interesting and quite possibly illegal situation at the moment of being eligible to vote in 2 different countries at the same time. So around this time last year, there was a big vote that piqued my interest in Scottish politics. I decided when the general election came around last May, I wanted to exercise my right as a non-tax-paying foreigner to have my say on how Scotland should be governed. So, basically, if you think of a government as a lot like a gene, right? A government is a lot like a gene. It's made up of a fixed number of subunits. Each one of those little subunits is made up of either one of 4 or 5 different things, right? You with me so far?
Yeah.
Now, based on the chemistry of these little subunits, some of them combine with each other, and some of them can't. A government is a lot like that. And basically, in a normally functioning gene, these subunits get on great. Now, unfortunately, during times of stress or evolutionary pressure, one of these subunits will be replaced with another subunit. And when that happens, it's called a single nucleotide polymorphism, or SNP. Now, SNPs cause great change. Some cause change for the good, some cause change for the better. I think that's really where this analogy ends, because SNPs cause change. Now, as a diligent and responsible scientist, it would be highly irresponsible not to mention that not all SNPs are good, and let's be honest, 57 SNPs within the same gene would undoubtedly cause fetal abnormalities. So, for lack of a better punchline, I just want to finish up by giving you some, imparting some wisdom I've learned over the last 2 years as a research student. Basically, any PhD students here? Any first year PhD students? No? That's grand, I won't say this bit then. Grand. Okay, so basically, point number 1. If someone in a more senior position than you starts off a sentence with, and as I'm sure you're aware, it will always be followed by something you weren't even remotely aware of. Secondly, if you sleep in the mornings, don't bother going into work until the afternoon. People will just assume you're coming back from lunch. And finally, if you go around carrying a poster tube without ever making any reference to it, people tend to believe anything you say. So, thank you very much, and enjoy the rest of it.